Hi everyone and welcome back to the channel. So in the last video we got the train running with the Arduino around the loop of track like this and into the passing loop. This update, what we're going to do is have the train stop automatically at the passing loop and have the other red passenger train start and travel in the opposite direction from the passing loop, and have them alternately do that every time one of them completes a loop of the track. So in order to do that, what we have to do is put in some sensors to stop the train at the passing loop, and we have to put in some switches to activate the points. So I'm going to be using Trix Bricks sensors, train detectors as they're called. These are IR sensors that the Trix Bricks company have installed in a 3D printed case that's compatible with the Lego base plates and Lego bricks. So that's the main reason I'm using these, and they're really good and easy to use, and we'll see how that works now. And likewise, I'm using the Trix Bricks servo motor for original Lego switches, and these are basically a servo. If I take this out, you can see the servo motor in there, again encased in a 3D printed enclosure, which is compatible with the Lego bricks. So, and there's a little 3D brick there that's made to enable you to click it onto the base plate or whatever it is, or whatever bricks you're using. I tend not to use these ones and just fix these straight on with the point switches. So this is for original Lego switches servo, and they have one for their own 3D printed Lego switches, which are really cool if you want to use battery powered trains, because they're not metal tracks. The Trix Brick stuff isn't. So we're going to install all these now. We'll basically clip them onto the layout, and when I do them, we'll show you how to connect up the wiring and then hopefully code it that it will work. So this is a little base that I've made here out of plates, so 3x2 plates and 1x3 plates. As you can see, the switch is in that position at the moment, and we want to match that with our servo. So our servo is switched to the right at the moment, so when that clips down onto the base, it's in the right position and the servo is attached to the switch. So the lever on the servo motor is pushing the switch in the right direction. So here we have our two sensors installed right beside the track. As you can see, this one is just sitting down on the base plate and the train moves past it perfectly. And the same with this one. We have used that 3x3 printed piece that comes with it just to give it a little bit more stability. This one didn't want to clip onto the base plate as well as that one, and that is, I suppose, one of the issues with the 3D printed pieces. So the two of these sensors are installed. Our switch is installed over here. And we're just ready to wire them up. So to connect everything up, as you can see, the Trix Brick stuff comes with these pre-molded plug tops on them, but we're going to use these standard DuPont wires to connect everything to the Arduino. We might have to use a connector block for the 5V power, but we shall see if we need to use that or not as we go on. So these are the DuPont cables that come with the come as you buy them separately. These are female to female, so they can be used as extension cables. These are male to female. Again, you can connect them on just to make them longer, and male to male. So depending on what you're connected into, you basically have everything you need here in one pack to do two trains, two sensors, two switches, and the Arduino. So guys, we got it working. We're really happy with the way it works now. We've got both trains running alternate directions for when they start off with the passing loop. So this one, as you can see, this is very tight to the switch points when it stops running. But I'll explain to you why that is the case and what we'll do to prevent that from happening later. So as you can see, alternately, they go around the tracks and return on, they stop on the passing loops and return in alternate directions. So we've got our motors connected here with all these wires, these jumper wires. Not a big fan of that. Normally I wire direct and trim some new plugs onto the end. And I'll switch these off. So well, I can't switch them off yet, and I'll explain that to you. Actually, there's a certain sequence that it has to be switched off in order for it to run, and that is when the white train is here. So we switch that off now, and as you can see, we've got all of these cables. We're using this breadboard temporarily. I will use connector blocks. I'll get rid of this breadboard and I'll connect these up properly now. But as you can see, what we have here is our 5 volts in, and this is our 5 volts out to the breadboard, and that's for all of the sensors power supply. So the 5 volts for each sensor and the 5 volts for each switch. So each switch and each sensor has a red, a brown and an orange cable, as you can see there. And each one, the red, so if we follow this one, the red is connected to the white cable, the brown to the grey and the orange to the black. So the white cable is going onto the breadboard here, and that is our positive because it's in the line, the positive line there. So that is the 5 volts positive. The grey cable is in the negative line, and the black cable is here. It's going on to this jumper, which is connected to this yellow, which is then connected onto an orange, which is then connected onto a brown, because you just can't be fussy, to be honest. And that is connected in here into the Arduino onto analog pin 1. So analog pin 1 is for LDR sensor 1, which is this. So in the code, when we say analog read, it's reading this input. So all we need is to get rid of this breadboard is the 5 volts from the Arduino connected in parallel to all of the 5 volts to the switches and to the LDRs. And then we'll have 4 wires going back to the Arduino in total, and that will be for LDR1, LDR2, and switch point 1 and switch point 2. So I'll do that now, and then we'll look at the code. So guys, after we upload all the code, we have it all working now. The main passenger train we've done our modifications on. So as you can see, we got rid of those the trans panels in front of that built-in battery box, and we repurposed the parts and basically cannibalized both sets. We had to add in 1 or 2 elements from our collection, but we've changed the look of those locomotives and taken away those trans pieces from in front of those battery compartments, and it looks an awful lot better. We also managed to build an extra coach, an additional coach that goes in the middle. It's in the middle because we don't have any additional trans parts out of the 2 sets. There's only 2. There's only 1 in each set. So we've managed to make a solid roof out of all white panels. So you can see when it goes around, there's a reason why it's stopped on this part of the track. So this is where the bridge will be, and the white train is stopped here. And I'll show you why that is now. With the code, when we start up the 9 volts to the track, it comes in here. Our red passenger train moves. If we stop the red passenger train here and then turn off all of the power, so the power is on here at the moment, you might see those little green LEDs. If we turn off all of the power, then the sensors have no power. The sensors don't know where the trains are. And if we switch on all the power and start the track again, and switch the power onto the track, what will happen is it'll try to run the white train first, because that is the first thing that the code does. So it's very important. I'll show you what happens here. So it's running the white train first, running the red train as well, and smack. So we'll just turn off the power there, and I'll put this back together and I'll show you the reason why. So with the white train stopped here in this section of the track, all the power is currently off. We'll switch the power on and we'll switch the 9 volts, and our train is running. So we'll switch everything off again. So this is a problem, and it's caused because of the first thing that the code does is it runs the white train. Now, the only way to do it effectively to make sure that nothing will happen when you start off is if both trains are in the passing loop exactly like that when you switch the power off. However, when this is covered with a Lego City, it's going to be nearly impossible to know when both trains are exactly where they're supposed to be in the passing loop. So we need to be able to stop it with the white train out here and then get into the siding and effectively not crash. So I'm going to have a look at the code and see if there's something I can do to actually prevent that from happening. So guys, this is the code for the new passing loop with both trains running, and yeah, with the point switching and everything else. And we basically made the code quite lengthy, if you look at it, I suppose, to in order to basically make the trains go in 2 opposite directions after they stop. So once they go around one loop, they stop and they come back around the loop in the opposite direction. So again, we're not using that many pins. Oh, sorry, to start off, we have to include this servo library. So this is to get the Trix brick switches working. We include this library here. Then we're using our IM1 and IN2 again. You might see that we've changed the pin numbers, and the reason for that is because we're now using LDR pins, and the LDRs are analog pins, and we're using analog 1 and 2, which would have confused the code if we had left the IM1 and IM2 as 1 and 2. So we're using IM1 and IM2 as 6 and 7, and the ENA is 3 as it was before. We're attaching the servos, or we will attach them later. So my servo 1 and my servo 2 are the track switches. This integer positive equals 1, I don't know what that means, to be honest with you. All I know is that I think I had to put it in previously in order to get the servos to work, and I think that's the position the servos at in a 360-degree arc where it starts off. So just to give it I suppose a constant to work to. So we then use what's called a state machine, and again guys, if you're thinking of doing this, please check out Arduino for Lego Trains, because his code and the tutorials on that are far superior than anything that I can put together here. But if you look at this, we've got this states. So there's 11 different states, and it's white train go, white train check, stop, red train go, check, stop. So that's the first sort of loop. And if we left it like that, the trains would continue to run around the loop. Each time would go in the same direction. And then what we did was to make them go in opposite directions every second time. We use these next states, which is white train go back, white train check 2, etc. So the byte state, and this is the reason why I'll show you later, that we have to stop the train. We have to stop the white train at a certain position of the track every time we're switching it off, is because it starts off with the white train go state. So once you put power on the Arduino and on the track circuits, everything goes into position, all the switches go into position, and the power goes on to run the white train go state, which starts the white train moving. We've got variables, LDR values, the LDR states as they begin, light sensor counters, light sensitivity, and that basically is the value at which the LDR switch on and off, and then timers. And I've just basically copied these from other programs and from Arduino from Lego Trains. I'm not sure where this code originated from. I'm just using it because that's what was there previously. So in our void setup, we begin the serial monitor. We attach the servos, and they're attached to pins 4 and 5. So that is the orange wire on the Trix bricks track switches, and they get connected to pin 4 and pin 5. And then we've got the same again as we had in the previous code, IM1, IM2, and ENA. The my servo write 85 and 68. What I've discovered from messing with the switches is that that is the degree from 0 that the switch has to turn to. So 85 switches the switch one way, 68 switches it another. And basically what happens is when the Arduino writes to the switch to say write 85, it goes 85 degrees one direction and it goes 68 degrees the other direction, and that has the effect of moving the lever and activating the physical track switch to pull it left and right and change the direction of the trains. So we get into the actual loop itself, and we start off with this new command switch state. So basically it goes from one state to the next, and that's why it's called a state machine. So the first one, the case is white train go. It's exactly the same pretty much as what we had previously. Analog write ENA 210, IM1 low and high, and that sends out the plus 12 volts to one track, 0 volts to the other track, and makes the train run in one direction. And you'll see later on with white train go back that these are reversed. So there's a delay here of 1500. 1500 is 1.5 seconds, and that's after it starts moving the trains. The code doesn't do anything. It doesn't allow any inputs from any sensors, etc. And that gives enough time for the white train to clear the LDR sensor and keep moving and not move to the next state. So this tells it then to move to the next state, and then there's a break. So that's the very first sort of piece of code. It's the very first state. So white train go, and it goes to white train check next, which is here. And that we start using the timers here. So it starts timing out after the code starts running, and then it checks the LDR value. And the LDR value, if it's greater than the light sensitivity, which is 500 above, the LDR state is 0. Otherwise, it's 1. And then if LDR1 state is the same or divided by the previous LDR state or LDR1 state, and the previous LDR1 state equals 0, you add 1 to the light sensor counter, and then you go to white train stop, which basically means my understanding is that this basically means if the light sensor just turned on, go to white train stop. And white train stop, again, we're using this counter, and we've got a delay of 250 milliseconds, which is basically a quarter of a second. And after the light sensor counter is triggered, a quarter of a second later, all power to the track will be cut. So that's basically digital write IM1 and 2 low low, and it cuts off the power. Then we switch the points. So if we go back up here, when we started off, it was my servo 1, my servo 2 were 85 and 68. And after the white train stops, my servo 1 and my servo 2 are 68 and 85. So they're switched around. Then the red train goes, and if we look at that, it's low and high, and it should be the opposite to the white train. So the white train it's low and high as well. So the motor's the other way around on the red train. So we've got the timers again, and it's pretty much a carbon copy of the white train going. And then you move down through it, and it goes to red train stop. When it goes to the red train stop, you've got low, low, cuts off all the power, and your switches go back to the way they were to make the white train run. However, when we got white train go back, we've got high and low it starts off with. So if we go to white train go up here, it's low and high. So this means it's going in the opposite direction, and it'll be the same for the red train when we get to it. So basically white train white train go back, we're going in the opposite direction, and we're going through all of the exact same steps again. We're using the same LDRs, we're using the same values, and everything will happen exactly the same way as it did before. And it'll keep going forever. And then we go to the red train check 2, etc. Red train go back. It's all just the opposite, but we're using the same sensors, the same timers, and the same LDRs, and the same pins, and everything else. So it's a really basic, simple code, and I don't understand it all completely. I'll be straight up and honest with you, but all I do know is that fiddling around with the values on this and actually changing some of the code and that here and there, it's great. It's great fun to do once it works. So, and it all works now, thankfully. Kinda. So look, I'm going to paste this code into the description below. If anybody wants to get an Arduino, hook up the track system to it and get a couple of TrixBrix sensors and TrixBrix point motors, this should work straight away once you connect it the exact same way. So just to remind everybody, if you are connecting up the actual Arduino itself, the physical connections are all here. They're the only pins you need, bar the 5 volts and your servo attachments here. So basically you've got 5 volts coming to the Arduino. The 5 volts powers the Arduino, and there's 5 volts powering each of the track switches and each of the LDRs. And then from each of the track switches, you've got 1 wire, and they attach to 4 and 5. And from each LDR, you've got a 1 wire, and they attach to 1 and 2. If you're using the TrixBrix kit, it's the orange wires that are coming back to the Arduino to attach that way. And then you've got your power output to, these are the 3 wires that are going to your motor shield, and your 9 volts gets connected to the motor shield, and these switch the motor shield, which in turn puts the 9 volts onto the track. Okay guys, so I shortened the delay in the code between the time the train starts and this sensor can activate. Well, basically I put in a really crude delay that stops anything else happening, like any inputs triggering or anything like that. But what we've found out is the white train still needs to stop kind of 2/3 of the way around towards the passing loop there. Once we stop it there, if we energize everything, turn everything back on, that's everything back on, then the train will run into the passing loop on the first cycle, but carry on through. And it'll stop this time, and the red train will move. So not absolutely perfect, but it does prevent any accidents from occurring. So we'll stop it here this time, and we've stopped it just 2/3 of the way onto the proposed bridge. And when we start it, it'll go back the opposite direction. It'll run through the passing loop, and it'll stop the second time around. Okay, so we're really happy about that, guys. It's another train system completely running, 2 trains alternating directions. So I think it'll look really cool once it's all finished and built up, and it adds another bit of I suppose some dynamics to the city. So yeah, a little bit of automation can't go wrong. I hope you enjoyed this prolonged sort of tutorial video, and until the next time, see you later.